hello everyone. Welcome to the Zero Gravity podcast. And today we are having the person who led the ISRO during the times the ISRO made the world record of sending 104 satellites in the space all together in a single spacecraft. Yes, I'm talking about the man who was among the key personalities behind the mission Mangal and Chandrayaan mission. So introducing before you Shri A. Kiran Kumar sir, the former chairman of ISRO, former secretary of Department of Space, and one of the key minds behind the various ISRO missions. Sir, welcome to the show. It's a privilege to have you with us.
Yeah, thank you. Thank you for this opportunity of having me in your
Okay, sir.
podcast.
So, initiating with the first question, we firstly want to tell our audience what a person behind the scientist is. Means how you started your journey, how the space started to fascinate you as a kid, and why did you choose this space sector as your career and all. So,
Okay, if you look at my own journey as a young child and then growing, I grew up in a place called Hassan, which
yes,
is actually midway between Bangalore and Mangalore. And Hassan is also known as poor man's Ooty. Ooty, probably you are very familiar, is a very
yes, yes,
well-known place of resort. And Hassan is in Karnataka, and
yes,
I was born in that place. And today we also have in Hassan master control facility, one of the ground stations from which we actually control the geostationary satellites.
yes,
So my life journey started in Hassan. In a family, we were a large family. I was born to my father's name is Dr. A.S. Mallappa. He was an advocate, and my
yes,
mother was Shanta Devi. And we were a large family, integrated family, and then grew up uh, in this small town. During the younger days, of course, unlike today's pressure, peer pressure, and learning pressure, we had a
yes,
lot of freedom. And then, as soon as we come from schools, we used to just leave our bag at one place, go out and play all kinds of games, cricket, badminton, and we're very much interested in all kinds of sports activity. But
yes,
then there was always a fascination of looking at sky, stars, constellation. So you're also identifying many constellations. And during one of the events where I was visiting one of the mutts in Hassan, the Swamiji there, from his drawer, he took out a small gadget and asked me to look through that. That gadget is actually, in many ways, you can see a device which can show you objects in 3 dimension. So you can imagine we were in 60s from a small town. Looking at something in 3 dimension was such a big fascination. So during our school days, of course, we were also participating in all kinds of sports and recitation, drama competition. So all activities we are interested. So generally, you can say very active in all kinds of fields, not just studies alone, but also in other areas. And then, of course, my entry into space itself was not very, in a way, means driven from childhood. Of course, during our childhood, we had opportunities to interact with great people. One
yes,
of the things that was happening in our own house was my elder brother had a fascination for creating simple gadgets. See, one of the thing was in our house, it was a, you can say, tiled house. In many of these old tiled houses, you will have a small hole and through which the sunlight will enter the room. So we'll close all the windows, and the shaft of sunlight which enters, we reflect it onto a wall and then create what you can say an overhead projector type of concept using simple things available at home. Take a mirror, reflect the sunlight onto the wall, so you get a bright patch. So in the path of sunlight, you write on a translucent paper some material, then it gets displayed on the screen. So in fact, my brother even used to create animations by moving that paper in a roll on a roll and gradually rolling it. So as the paper moves down on the screen, you can see what you are projecting is coming out nicely. So with simple gadgets available at home, the concept of overhead projector, you can imagine this is the mid 60s. Even
yes,
overhead projectors are not very popular at that time.
yes, sir.
And that was one of the things that was being done. And another brother of mine was very much interested in doing chemistry experiments. He will have
Yes,
a beaker, then sodium, phosphorus, all that, potassium permanganate. So we used to do a lot of experiments like that and enjoy. And being a big family, we were also used to doing all kinds of activities from drawing water from the well. So in a way, you can say exposed to different aspects of life, and then trying to, in a way, enjoy everything that we are doing. And then this journey to space itself happened much later in 1975 when I was completing my physics honors, after physics honors from a college in Bangalore. I was, after MSc, I did a course called Master of Technology in Physical Engineering. And that course, we developed, a laboratory in IISc had developed an instrument called a drum scanner.
Yes.
Again, in mid-70s, even copiers were not popular. We didn't have any cop. But the gadget was built which could convert a film into an electrical domain by passing light through the film. And as the drum rotates, the film, through the film, a signal, light signal passes, and a detector on the other side measures the density changes on the film. And this is converted into an electrical domain, do processing, and write it back to another film. The idea was, see, many times X-rays and angiograms which are taken, the film might not have got produced well because of certain limitations or
Yes,
process.
sir.
So
Yes, sir.
we were trying to build in image enhancement techniques. So for doing image enhancement, first you have to convert the film into an electrical domain. So such a gadget had been built, and I had the opportunity to work on that. And so we were working with doctors so that the film, the patient doesn't have to be subjected to one more round of exposure if we can enhance the film and make the doctor see what he wants to look at in the film. See, otherwise, what used to happen is if the film has not developed well, the doctors have to subject the patient to one more round of the X-ray or angiogram, etc. So we
Yeah.
were trying to do such a project. This is happening in 75. And in 75 is when India launched its first satellite, Aryabhatta.
Aryabhatta.
And that Aryabhatta satellite, in April, it had been launched. And I was completing my course in July of 1975. So the director of, project director of that particular program, Aryabhatta, had visited our center in Indian Institute of Science, Bangalore, and he gave a lecture in the Senate Hall. So we were listening to that, and that's how I got actually interested in that. And an advertisement came out just around that time in Ahmedabad for a program called Satellite for Earth Observation. So I had applied for that, and I got selected. So because of my work in image processing and also physics background, so that's how I got an opportunity to work in ISRO way back in 1975, just when I completed my course in Indian Institute of Science, which was actually in a way an interdisciplinary course devised at that time. Today we talk a lot about being well versed in many disciplines. So that time, this particular course was working for vacuum engineering, nuclear engineering, solid state physics, electronics, operations research. All that was being taught in that course. So that's how I started my journey of getting into Space Application Center, which was one of the ISRO centers at the time. And that was my childhood and growth to space activity as a starting.
Okay. So in this conversation, you mentioned a very special thing that all of our youngsters and I should also follow, that you were having no peer pressure and you followed what you wanted to. Means you developed a projector in 1960s, which no one can even imagine that a person from scratch can build a projector and they can also demonstrate something in that. So with this message, I want to convey to our youngsters that follow your passion, do whatever you want with no peer pressure. Everyone will say you something, as those times were not having so much peer pressure. Parents allowed you to do what you wanted, but today the parents are just not just parents, the whole society is behind you to push you into some limited fields like medical and engineering. So the children are not getting enough means freedom to choose what they
Mhm.
want. Yeah. So moving ahead, you mentioned that you worked on a satellite to observe Earth, and I think that was Bhaskara satellite,
Yeah,
and
correct.
with
That was
which you
Bhaskar.
started your career. And so during that time, ISRO was just it was a budding organization and initiating its journey into space. And now ISRO is someone who is not just sending its own satellites, sending the satellites from various other countries. So, sir, how the time has changed, and what were the complications and means challenges you faced during those times of making a satellite and launching? Means what was the era and how you felt during that time?
See, obviously, as you can see, 1975 was just when the first Indian satellite built was launched from Russia. This was called Aryabhatta.
Yes.
And then Russians also had offered, we will launch a couple of satellites for you. So we were building a satellite. This satellite for Earth observation
Yes.
is our starting journey of building a satellite to look at Earth and take pictures of Earth. So obviously at that time, everybody is new. Nobody knows exactly what to do, how to do things. Just one satellite had been done. Now we were required to build a camera which can look at Earth. Now satellite itself, if you look at, it was a spinning satellite. That means normally when an object is in orbit, to make one of the ways of taking care of thermal distribution is make the object rotate about its axis so that no one face receives sunlight all the time. See, otherwise, if you are having an object in space, one face is looking at sun all the time, then that face gets heated, other side becomes very cold. There will be very uneven distribution. So if you are rotating that satellite, all faces by turn take the heats and equilibrium come. But then the problem for us is, for us from a spinning satellite, if you have to take a picture, you have to make sure that you expose your camera exactly at the instant when the lens axis is pointing to the center of Earth. So
Yes.
you have to find out when that is happening, build some mechanisms for that. That was
Yes.
one of the things.
Yes.
And we were building for the first time, like I said. Then the second thing was we were also trying to put observation in two wavelengths, one visible and another just beyond visible. So the sensor that was there, a VDCon camera, had a capability to operate only in the visible. So we added to one of them a image intensifier. Image intensifier is a device which magnifies the signal so that you can get better images. And then this was also converting from one wavelength to another wavelength. But the problem was this image intensifier required very high voltage for operation, something like 14 kilovolts. See, we were building a satellite based on solar panel and power. It generates few volts, 10 volts, 15 volts, 20 volts. But then from 20 volts, you have to create 14 kilovolts. So you
Yes.
require a different electronics for converting it to that. And that had to be built. Second thing is, like I was saying, the satellite was spinning. So when a spinning satellite, if you put an image intensifier has an on to off ratio. You cannot, you are exposing it for a very small time, the duration of few milliseconds. But then between two images, we had to take almost 30 minutes, 30 seconds, because the transmission data rate capability we had in the satellite was very limited. It
Yes.
was only 90 kilobits. See, today we are talking of gigabits, megabits. That
Yes.
time it was only kilobits. So within that, if you have to transmit the entire data, it used to take almost 30 seconds. You take a picture, transmit it for 30 seconds, take the next picture. That's how it was configured. But the point is, all of this is new. Building a payload is new, building a satellite is new, how to test it, what. And obviously, this was all satellite technology area. Unlike today, information access also limited. You have to read only in books or magazines or journals. Obviously, you will see journals also by the time it reaches us would be many years after it is published. And then publishing itself will be many years after it has actually happened. So we
Yes.
did not have latest information or anything. We had to build all this by trial and error and then whatever minimum knowledge that we were able to get from various inputs. So that's how we started. So the whole process of building the first satellite took us almost 4 years from 1975. 1979 is when we first launched the Aryabhat Bhaskara satellite. So
Yes.
during this period, everything was for a first time. None of us knew what exactly, we don't have experience. So we are all learning by trial and error. And also the only constant goal is we have to make it happen by the deadline so that the satellite is taken to Russia, launched, and then set up. So that's how the activity was going on. So while it was a lot of challenge, it was also a lot of, you can say, apprehension of how it will come out, what will happen, whether it will work or not work, all kinds of things will be there. But then you are no, because you have taken up the challenge, now you are committed to delivery. So we were all working together, many of us who came from institutes and various other engineering and other institutions in the country were working together, and step by step we learned how to do it. And the first satellite was launched in 1979, and it was done in an era where information access is limited. And then you have also, you can say, the only calculator we had was actually a plasma display tube or DCM calculator. That was the kind of thing that was there at that time.
Okay, sir. So you have led the design of 50 plus electro-optical imaging sensor. So how did they revolutionize the eyes of India in the space?
See, if you look at, like I said, the first imager we developed was having a camera which could take a picture of Earth 340 kilometers by 340 kilometers with
Yes.
1 kilometer resolution in
Yes.
two wavelengths. And
Yes.
then we were transmitting the data, take the data, store it, and then transmit it over 30 seconds. But then by the time sort of I completed the journey there, we had come down to 30 centimeter resolution, and with data rate going up to almost 600 megabits, etc. And then providing images of India and the globe at 30 centimeter resolution in many wavelengths, not only operating from low Earth orbiting platforms, but also from geostationary platforms. The advantage of geostationary platform is you can get practically continuous imaging if you have the necessary communication capability, etc. built. So
Yes.
we built from very coarse resolution two-channel imager. We had built high resolution cameras, multispectral cameras. Multispectral means you can look at objects in many different wavelengths. See, for example, in our mobile, when you have an color picture, it comes because you have three red, green, and blue. So similarly, if you take any electromagnetic radiation, there is a large number of wavelengths. You can choose in which wavelength you are operating. Visible, if you look at, you need an alternate source. Sunlight is present, so the satellite, when it looks at Earth, if sun is illuminating that region, you can take a picture. But then in the night, if you want to take a visible picture, it is not possible unless you carry a flash. But then you can imagine carrying a flash on a satellite will be practically impossible. So, but then you use different wavelengths like
Yes.
infrared, microwave, and there also why you use different wavelengths. See, certain wavelengths are transparent to the see in the atmosphere. If you see, when we are seeing visible light, if cloud is there, we cannot get anything. If you look at from an orbiting satellite, being in the monsoon period in India, practically between June to September, you have cloud cover. So you cannot get good images, etc. But then instead of operating in visible, if you operate in microwave,
Yes.
the like glass is transparent to us for
Yes.
visible light, clouds will be transparent to microwave. So if you use a microwave camera, you can collect information about that. So the point is you have to build your observing systems operating in different wavelengths, different resolution. Four important resolutions are there. One is spatial. That means what is the size of the pixel? Like I said, we started with 1 kilometer resolution, came down to 30 centimeters. That means you can clearly identify cars, vehicles, etc. on the road. Whereas 1 kilometer resolution doesn't give you any such thing. It gives you a very broad picture. Then temporal. How often can you take? Can you take images every few minutes or every hour? For that, you are using a geostationary satellite. And then in terms of digital numbers, if you see each pixel, how many digits are there? Intensity can be put in 10 bits, 15 bits, etc. So spatial resolution, spectral resolution, radiometric resolution. So like that, there are four resolution. Your ability to get more and more information depends on all these parameters. So we went on building progressively more capable instrument so that we can work for providing like cyclone. You can predict when exactly a cyclone hits a coastline, or by looking at the color of the ocean, you can identify where the fisherman has to go for catching fish, or by looking at the fields and crop, you can tell ahead of harvest what is the likely yield of rice, jute, wheat, sugarcane, a whole lot of more than 20 odd the, the crop products you can pick up and tell the government ahead of harvesting what is there. So for all this, you have to build instruments, and these kinds of instruments is what we were building during the course of our journey in Ahmedabad. So more than 50 electro-optical units, starting from a simple camera to the most complicated camera. Another yardstick you can see, first camera we had built made use of a lens with an aperture of 50 millimeters. But then one of the most complicated telescope we had built had a 1.2 meter diameter mirror, a mirror of the size of 1.2 meters. So you can imagine the complexity increasing, electronic speeds starting from kilobits to gigabits. And like this, everything went on becoming more and more complicated and more important.
Okay. So we can say that the means boundary of universe is unimaginable. And so our imagination is also very unimaginable, as human can go around anywhere where he wants. So there is a basic question: why do we need to explore this universe? Why do we need to explore this space? What we will get from it? Means what is the benefit? Why we are spending a lot of money in exploring space?
Okay, now if you want to look at this from the very basic fundamentals, if you see,
Yes.
what is it that the human being does? See, just imagine human being from the very early points in time. So the way I try to look at it is each of us, each human being has an ability to look at the world by virtue of his five jnanendriyas. He has five sensors on the basis of which he can get any input.
Yes.
Similarly, he has five karmendriyas using which he can do any function. For
Yes.
example, using hands, we do our work. All the work we do using hands. Then
Yes.
similarly, legs are used for transporting us from place to place. So
Yes.
you can move around using your legs. Similarly, you have a voice generation system. That
Yes.
is the one which you use for communicating, making known to people that what you want to convey, etc. So like five sensors you have, five karmendriyas you have, three we identified, two more I'll leave it as homework for people. So
Yes.
we are endowed with five karmendriyas, but then we are also endowed with an intelligence. That intelligence take the sensory inputs and then creates action by operating the actuator. See, for example, if I were to ask you, for example, what's your name? Then you will say, my name is such and such.
Yes.
How did it happen? Your controller, the intelligence which is operating to you, heard the sound which came, and for that sound, it had to create a response by telling an answer. And
Yes.
that it did because it had within it knows that my name is such and such, which I have recorded. So I'll pick it up and operate my voice generation system and deliver. So basically, what I'm trying to impress is we have got this intelligence which is running us. So what is it that happens in a human being? This intelligence is all the time trying to not only take care of this platform, but also explore what is around. You can visualize humans when they started their life's journey on planet Earth. Their physical strength was not adequate to fight with bigger animals.
Yes.
There were many bigger animals around. For their own survival, they had to find mechanisms. So
Yes.
first, what they had to find, their physical strength was not good enough. But they kept observing. They saw there were some hard objects, picked up a stone, started using it for fighting. Similarly, there were branches of trees falling around. They took a stick, they started fighting with the animal from a distance. So that means they overcame the limitations of their actuators to survive. What was the inspiration? What is happening around them in nature? So they picked up stone, they picked up stick. Then some people became very proficient in using sticks. They converted it into bow and arrow. So then you can imagine that group which converted this, created this bow and arrow became a dominant group. They were able to take control of others. But before that also, if you see, how many kilometers can we walk in an hour? Maybe 5 to 6 kilometers. But
Yeah.
humans saw there were other life forms moving. So they domesticated, started riding them. Why? Because they thought they can travel, they can see farther and farther places. Their own legs, if they are using, they'll be tired. So they made use of animals. They started domesticating and riding them.
Yes.
That means what I'm trying to impress is the intelligence which is running the human system is trying to overcome the limitations of its actuators and sensors and then explore the world around it and then find a better way of living. So in this context, if you see, another thing that happens is human eyes can see to start with only when sunlight was there. That's where daytime, nighttime actually determined his living condition. During daytime, he could see. During nighttime, nothing could be seen. So he was taking rest, let's say. But then he also realized what his eye cannot see, there were other life forms which are seeing, owl, bats. Then what he did, he started mimicking that, created tools which could help him look at how universe is visible in a wavelength beyond what your eye can see. So you can see in that context today you have got infrared camera, you
Yes, sir.
have built bats or this thing,
Yes.
radar, sonars. So
Yes.
like that, if you see, everything human being is trying to do is expanding his ability to look around, explore. He saw birds flying. So yes, you know what he has created. He saw on the water some swimming object. So he started swimming, he started boat, ships. So that means his all the time desire is to look around, explore, and then keep moving and improving his own way of surviving,
Yes.
both by converting them into groups, forming groups, living as a entity, etc. But in all this, the fundamental point you need to appreciate is intelligence which is running this human system. Is it operating on a principle which says mimic what is happening around you and evolve yourself? That means the intelligence is simply taking the sensory data and then mimic it by creating appropriate commands for sound generation and
Yes.
hand movement, leg movement. And then by this process, by looking at what is happening around you with other animals and other life form and nature, build your own ability to not only survive, but also build gadgets and tools which will help you overcome your limitation.
Yes.
So now if you take this as the primary principle on which human system is operating, then you will see exploration is a very intrinsic nature of human system. Again, I'll give you another very simple example.
Yes.
For example, all of us enter this world as a child. When we enter this world as a child also, all these systems are there with us. Our sensors are there, our actuators are there. There is an intelligence within us which is operating. So how does this intelligence start its initial journey if you take? Now, for example, what is your mother tongue?
Hindi.
Hindi.
Yeah.
My mother tongue is Kannada.
Kannada.
Suppose you were born in Karnataka, you also would have learned Kannada. If I
Yes.
was born in any Hindi speaking state, my mother tongue would have been Hindi. Now,
Yes.
can we just analyze why it happens? The intelligence which is running this child's platform is simply listening to the sound being made by the people around.
Yes.
Lot of sounds are being made. So initially, intelligence doesn't know what is happening. It is
Yes.
simply observing, taking this sound, recording it, and based on the sounds, people are interacting with them.
Exactly.
Then it is also trying to write its own rules of interpretation,
Yeah.
rules of operation. So it says this is a bottle of water. Why everybody else calls it as water and bottle? Similarly, paper. So this intelligence also starts writing its own records. So this sound means this. Then it also tries to reproduce the sound. So it tries to generate command. See, when a voice you give a command, that's how it delivers. So it starts building those commands itself. Similarly, getting up, walking, moving. Now you can imagine everything a child does is because that intelligence which is operating that child is learning step by step and
Yes.
experimenting on it by itself and then
Yes.
growing. Now, if
Exactly.
you look at this, one of the key drivers operating in the human intelligence is mimic what is happening and evolve yourself.
Yeah.
So does it not require exploration? Does it
It
not ask
was.
questions? What is this? What is that? How does it happen? That's why
Yes.
if you see a young child is so curious because it is all the time trying to learn, try to find out. It keeps asking questions. But what happens in the surroundings for until some point of time, people around us keep encouraging us.
Mm.
They showcase us when somebody comes to our house, they'll tell, hey, look at my son, my daughter, such brilliant questions she's asking, he's asking. They showcase to the people. But very soon, what happens? The questions we ask, they don't have answers.
Yes.
But then, what is a nominal human problem? As long as I know the answer to the question you pose, I'll be actually inspiring you, actually promoting you in a way.
Yeah.
But then, the day you start asking questions for which I don't have answer, I don't want to show my ignorance to everybody, to you also. So, what will I do? Hey, keep quiet, don't do this, don't do that, you are useless, etc. etc. You
Yes.
start suppressing them. So now you see what happens to the child. Child is trying to ask questions and learn. But if a lot of people around it says, you are useless, you are stupid, you are this, that, it will decide, why get into this trouble of asking questions? Let me not ask questions. So it
Yes.
will stop asking questions.
Yeah.
That's how it evolves. So that is where when you say, when a human system evolves, depending on the environment they get, depending on the stimulus they evolve. So in
Yes.
that context, if you see, you will realize humanity has grown step by step, building one step at a time. You saw birds flying, you started. First set of people simply put wings and tried to jump from mountain.
Yes.
They broke their leg and all that. But then
Yes.
some people started realizing that there are different ways of doing. But everything was inspired by flying birds.
Yes.
Similarly, ships. So if you see, everything is an inspiration in nature.
Yes.
You have an intelligence which is trying to drive you to improve your ability to explore the world. So now
Yes.
you see what happens if you are seeing moon, or if some, like, somebody was asked, why do you want to climb Mount Everest? He said, I want to climb Mount Everest because it is there. That is a challenge. Similarly, somebody thought moon is there, I want to go there. So like that, human tendency is understand. Not only that, if you really look at much more fundamentally, you want to live a better and more comfortable life. So you
Yes.
imagine again very initial days. If the sunlight comes and goes, if you look at night sky, there are lots of patterns. There is some familiarity in the pattern if you keep observing day after day. Then they started realizing that there are movements. If you look at sun position in the backdrop of stars, they
Mm.
could locate where the sun appears and how it changes. Then they realized there is a periodicity. They started recording, and then they started realizing when sun, moon, or some star, it is in some position, it rains. Other time it becomes hot. So they started correlating, and then it helped them survive better for tomorrow because now
Yes.
they could anticipate
Yes.
when will it rain. So that means this whole process of understanding what is happening around you is a constant evolutionary process.
Yes.
Today, if you see, all the time, what you are trying to see is improve your own existence,
Yes.
make observation, do analysis, and then create things to help you survive better.
Yes.
So this is a constant process. Now you see what happened. You are exploring. You are exploring the external world. So if there you see something, you want to understand why it is there. And then based on your understanding, you are building tools. So initially you built some things for storing, something for retrieving, and then you built computers. Now, as the computers are becoming more and more capable, you are able to build models. So now you are trying to explore this universe. So whatever is there, you want to understand. If
Yeah.
other planets are there, other solar systems are there, you want to understand why it is working, how it is working, what is this universe, who am I? All this is a question mark. A question which your intelligence is trying to find an answer, both by collaborating and by exploring.
So, you emphasized a very important point that whenever we look into the sky during night, you people used to see everything during daylight, and that is what made them curious. And during night, they used to see nothing. But there was some instinct in their mind that something may be there which we are not able to see, but various other creatures can see that. And it correlates with the thing that whenever we used to sleep on the roof in our villages and all, and whenever we look into the sky, we see that the immense unlimitedness of the universe, or we can say the sky, we see stars, we see moon and other planets there. So it was something that you addressed in this whole conversation, that there was some sort of curiosity in our mind, even as a child, that was seated during that moment, and we wanted to explore that what is beyond that we are seeing. So that might be the driving factor which drives us to explore the universe. So while Vikram Sarabhai sir and he was initiating um, INCOSPAR, various people asked him that during this fragile time of our country, the condition was not good. People used to starve, and we were nothing economically. So during that time, he thought of initiating or building upon an organization which will explore space. People used to ask him that what is the need, means how will it will help us, and at this fragile time, why do we need that? And now people are seeing its benefit, that it is helping in defense research and whatever we can say, the climate change and all. So, sir, I want to ask a very simple and basic question, that what are the tangible everyday benefits that people of any country are getting from satellites and the space program?
Yeah, if you look at, for example, on a Earth itself, you want to understand when it is raining, weather, etc. If you see,
Yes.
when it rains, when cyclones come. In India, if you look at cyclones, when it hit the coastline, there's a huge loss of life. Tens of thousands of people lose their lives. Why? Because you do not know when the cyclone is going to come. Now, if you want to understand, start making based on observation, you want to predict when will such an event disaster occur. So now, till satellites became available, what was the ability of humans to make such predictions? If you look at
Yes.
what will be there, you have to make observation. Observation they can make over land where they stay. If you look at Earth, 2/3 of the Earth is oceans.
Yeah.
Over that entire portion, there is no data available. So in any model, if data is not there, how will the model be able to do any prediction? See, the once satellites became available, the entire global information of wind, sea surface temperature, various atmospheric parameters could be picked up. And then using that, you could now get into models and then based on the model, predict days in advance. Today, if you see in India, these super cyclones, when they hit the coastline, loss of life is restricted to a single digit.
Yeah.
So ability to do weather predictions at a very high accuracy and disasters became a possibility because of space-based observation. This is one. Now, second thing you see, you want to communicate information, disseminate information. Again, like you were asking, 1957, when first Sputnik was put into orbit by Russian, India was a fledgling democracy. Just 10 years into independence, after centuries of external rule, with an economic condition so poor that if somebody were to talk of doing space activity, like you're asking, there would be a lot of question mark. But then what Dr. Sarabhai had visualized, it is only using space technology can we rapidly change the
Yes.
scenario in the country by bringing in communication, broadcasting, weather monitoring, and resource monitoring activity from space. If we can do, we can quickly change the scenario in the country. I'll just
Yes.
give you one example to drive home the point.
Yeah.
Like you were saying, obviously in 1957, when Russia put the first satellite into orbit, if somebody were to talk in India, we want to do some activity in space, powers that be, those who are ruling the country, would really say, what are you talking about? We are struggling to provide food, shelter, and education to citizens. We don't have money to do anything in space. Now I'll do a little later. 1975, India conducted an experiment called SITE, Satellite Instructional Television Experiment. What was done in this? A satellite built by America was borrowed, moved over India. For 1 year, using that satellite in 2,400 villages of our country, using a concept similar to our direct-to-home television. Instead, today, what happens in direct-to-home television? You have a quarter-meter antenna on your rooftop, a set-top box. You see the program on TV.
Yeah.
What the satellite is beaming.
Yes, sir.
Now you go back 50 years. In 1975, ISRO demonstrated to the country that in 2,400 villages, a 10-foot diameter antenna with half a rack of front-end electronics, with that, in those villages, programs were shown and broadcasting was done for 1 year. And now, after demonstrating this, suppose you go to powers that be in the Delhi and tell them, again, now think, you are in 75. At that time, you tell the powers that be and tell them what you are speaking can be heard all over the country at this instant. Will they agree to your proposal?
Mm.
At that time, they will easily agree because
Yeah.
what they are speaking can be heard all over the country.
Yeah.
Whereas in 57, they cannot visualize.
Yeah.
So after this experiment was conducted and shown, then the program got approved and went ahead. So broadcasting, communication, then weather monitoring, all that became a reality. And you also know for fishermen, we give information about prospective fishing zone. A
Yes.
person who does not know reading or writing can make use of it. So like this, space brings to you. Today, you know what is happening can be seen on your gadget at this instant of time.
Yeah.
Whereas in that time, if you have to send, you have to maybe write an airmail or a post, which will go by ship or air and take months to reach. So space has enabled you to connect the entire world. It has enabled you to see what is happening on Earth. It is enabling you to see weather forecasting and prediction. Survival on Earth is being improved. So without space, ability to operate from space, whole lot of activity which happens on Earth would not be possible today because you have got so much used to these facilities. If tomorrow, for example, a whole lot of satellites stop functioning, there'll be chaos on Earth.
Yeah. So, as a scientist, how do you see the space? Means you said that you were interested in writing poems and reciting them and doing other literary activities. So, how you can philosophically think about space, not just about scientists, scientifically or economically? Means what is a space according to you philosophically, or we can say how you take spirituality and a space and sciences together? Means, are you understanding my question?
Yeah, I know. Okay, I'll answer you what you're trying to tell. See, this is where what is every human being actually trying to do if you look at.
Yeah.
One of the thing is you are navigating your journey in life.
Yes.
You're moving on. So now you have some intrinsic system of what is available to you 24/7 is your system consisting of your intelligence, sensor, actuator, this body, etc. Whatever.
Yeah.
So now you are trying to do different things for living in harmony with the surroundings. So some things interest you. For some people, it is how they can communicate in a poetic language, what they have understood, what they have seen, etc. Reciting in poems or music, dance, arts, everything is in some way expressing your own experience of life in a manner in which others can appreciate, or even whether I appreciate or not, simply it is your endeavor to bring out what you want to do. That is one of the things. Now, in science and technology, what is happening? People are putting effort to create systems, tools, and gadgets so that life can become easier, simpler, and understandably less effort on human being. So lots of gadgets are built to reduce your physical labor. Lot. So like that, when you are doing, you are thinking about all this. So now, if you try to understand what is this human system,
Yeah.
how is it operating, why are we there? If you start looking at today, like when I was giving you that example of what is a human system, I compare it with a robotic system. Today, you know what is a robot? You have designed a robot for performing a function.
Yes.
You have built in that some input taking element, sensors, some performing actuators, one controller, and in one memory you have stored data, and using that data, the controller operates the actuator. Simplest example, if you take a mixer at home actually grinds or chops and converts into pieces. So there is a controller in that. Blades and motor forms the actuator. Switch forms the input mechanism. You put switch to one position, mixer runs at some speed. Another position, it runs at a different speed. So you can say there is a controller inside. Taking the switch position, it operates. Then there is a memory like that. So a robot is a system with sensor, actuator, controller, one memory. Now, if we look at humans, when we started our journey in this world, we also started journey with the controller taking input from the sensor, and it started doing data analysis, data coding, command generation, commanding, all it stored in one memory. And then we started evolving ourselves. But then you also now start wondering, how is all this operating? Is there something beyond this? Can my controller see the world beyond my five sensors? Are we limited by only these five sensors? What is our dream? What is the meaning of this? What is this world? Why are we on this planet? So like that, if you start thinking, a
Yes.
whole lot of questions come to your mind. So
Yes.
what this land did, these questions which are there, they try to find answers in different ways. See, in science and technology, you are exploring by conducting experiments outside. But then you can also think about your own internal self and visualize how your intelligence is operating. What are its limits? Can it do something more than what we are all now talking about? Is it limited by only these five sensors? I'll give you some simple examples to drive home this point. Today, you have a mobile in your hands.
Yes.
What is this mobile doing? For example, if you take this mobile, in the same environment, this particular gadget receives information and decodes, decrypts, and then shows to us as an audio and video. So that means outside the physical boundary of this object is able to send and receive information.
Yes.
Now, how did this gadget become a reality? What was the process which humans went through by which they created this gadget, and today you are using it? Now, you remember earlier I told humans started their journey by looking at what is happening around and started building simple tools. You
Yeah.
picked up stone for survival, sticks
Exactly.
converting into bow and arrow, their legs, they domesticated animal. That means here also there is a concept which says some information can be sent into the universe and received back. What this mobile is doing is giving it to the universe.
Yeah.
From here it goes somewhere. Somewhere else it gets picked up by another gadget. There it decrypts, decodes, and shows it as audio video.
Yeah.
So if this device has become a reality, who took what inspiration and created it? One other thing we realize is nothing in this world has been created by a human, the concept of which does not exist in nature. So if you think like that, now can you think of how did this gadget become a reality? Somebody must have visualized things like this are happening. So you have
Yes.
also heard you have heard things like telepathy.
Yeah.
That means you also know some people are able to read others' mind. A whole lot of capabilities exist in the universe.
Yes, sir.
Are they people who have turned on in their robotic system mechanisms which are available for, let's say, practically everybody? Because we don't know what it is and how it operates, we are not able to use it.
Yeah.
Suppose that switch you turn on, would you also be able to do something similar? Atindriya gnana. You have got five gnanendriyas.
Yeah.
So with those indriyas, you are taking data and processing.
Yes.
So like a mobile, if you are also able to pick up data from the universe, you can also learn something very different. Now the question is, again, you know, as both as a student and a teacher, knowing is never adequate. Translating what you know into action demands effort, persistent, focused effort to make it happen.
Yes.
So if you are ready to do that, then you can realize many things which we become aware. Similarly, today, for example, you know there is an electron microscope.
Yeah.
Just knowing, can you build it?
No.
You have to go through the whole process of taking all the parts, assembling them, making it work. That means you have to put in effort
Yes.
to translate what you know into action.
Mm.
So now you come back to what I was trying to tell. Your intelligence is trying to understand based on the five sensory inputs it got, but it also has other kinds of experiences. It is
Yes.
seeing some people capable of doing certain things.
Yes, sir.
So it's trying to figure out how it is happening. Can you also send signals? See, today when you do virtual reality or magnetic resonance imaging, MRI, picking up signals just outside your body, today, you know, there are gadgets which can pick up the signals that you are transmitting. Based on that, it can measure your heart rate, etc., without contact, isn't it? So what does
Yes.
it mean? There are some things this gadget is doing. By building appropriate sensors and detection and processing, you can understand. What is an MRI doing? It sends an electromagnetic radiation. interaction of that radiation with your biological cell produces some change. By signal processing, you pick up that change.
Yes.
Same way, when we are seeing star, signal came when it's left that, but you have a sensor which is telling.
Yes.
So you are now able to make better and better sensor, more and more capable sensors,
Yes.
more and more capable processors. Your modeling capability is increasing. That means you are trying to put all together. So you keep improving your sensor, you keep building better actuators, better transport system, you build better processing system. But in all of them, you are mimicking what is present in nature. So today, if you take that aspect, suppose I were to ask you the question, what are people trying to mimic in AI? AI is also creation of humans now. They are
Yes.
trying to mimic something present in nature. So
Yes.
are they trying to mimic something in AI? If they are trying to mimic, what is it? What do you
The
think?
intelligence,
Yeah. Whose intelligence? Today, the best intelligence they know is human intelligence.
human intelligence.
So you are trying to replicate the way human intelligence operates in this AI.
Yes.
Even human intelligence also, continuously effort is going on. Neuroscientists and a whole lot of people are trying to figure out how to measure something, how to correlate, how this is operating. Now you also realize, earlier when systems were realized, they were making hardcore predictive decisions. Systems used to only give predict, but then very soon they modified it to fuzzy logic, neural networks.
Yes.
Why? Because intelligence in lives operate in this manner. They found that this is an effective way of dealing with things. So
Yes.
they modified their decision-making systems
Yes.
to fuzzy logic, neural network based. So now, as you are able to build more faster, more capable machines doing intellectual activity, you are trying to do machine learning, artificial intelligence in them, trying to mimic your intelligence there.
Today, after ISRO has achieved a lot of milestones in the space, various youngsters and people like me are willing to join ISRO in their career. So, sir, what is your message to them? As how would you like to inspire them that what should they develop in their personality and that makes them sufficient or that makes them ready to join an organization like ISRO?
No, my suggestion is it is not just ISRO. Any activity you do, you have an infinite potential.
Yes.
Try to become aware of yourself and then maximize what you have. See, first and foremost thing is like I'm trying to now bring out, you have your 5 sensors, 5 actuators, and intelligence, you have got a memory, you have inherited something. You try to figure out how you as a system is operating. Today, you are limited by your experience till today. If you expose yourself to more and more different things, the intelligence which is operating in you has infinite potential. It can grow. There is no limit. Actually, you are limiting yourself by thinking certain way. But if you start figuring out how you can make the best use of the platform that you are having, you can achieve phenomenal things no matter what field. Space is only one aspect of life. Life has so many different things in
Yes.
every one of those areas. And again, you have to visualize there is nothing like science and non-science, arts, commerce, etc. Today, unnecessarily, we are making a distinction.
Yeah.
Is there any human activity which does not require special knowledge and special skill?
Every field requires.
Process of acquiring and making sense of that special knowledge is science.
Yeah.
Even if you say you are drawing a, let's say, rangoli, even that there is so much of finer information. How you can communicate using those drawing information, and then how you can make the line sharp. So many things come into that. Every human activity requires acquisition of special knowledge and use of special tools. The process of building those special tools is technology.
Yes.
Process of acquiring and then generating that knowledge is science. So science and technology is present in every human activity.
Yes.
And humans have that capability and that innate drive in them, innate intelligence in them to deal with it. If we start becoming more and more aware of our own self and then try to do, again I said, just knowing is not good enough. You
Yeah.
have to focus, dedicate, persevere, then you can achieve whatever you want.
Yes.
So become
Uh,
more and more aware of yourself.
Yes. So recently we saw a very great success in the in the field of private sector. And I saw that you were also sitting at the mission control besides Somnath sir there. The two boys, the very young boys, and that whole means we can say the organization is filled with youngsters of the average age of around 28 years, and they are building a rocket for our space program to send our satellites into space and just pioneering the world in their first attempt. So, sir, what the message you may convey to the audience, that age is not just a factor, and how do the young generation may follow their passion and do the same stuff in their own fields to achieve such a great success?
Yeah, this is where fundamentally what we need to appreciate is
Yes, sir.
potential is enormous. Now,
Yes,
translating potential into reality requires dedicated, focused effort. If you take this example itself, in 2018, when both Pawan and Bharat actually they were part of a LVM3 program, they
yes,
decided to leave, start even before the space policy had been announced. But then, by persevering and focused, dedicated effort, they have put together a team of 1,000+ people and created this. So what
yes,
it shows, potential is infinite, but
yes,
then it has to be backed up by perseverance and not giving up under adverse condition and then dedicating yourself. The real challenge is here. Knowing is one part of the story. Then
yes,
translating what you know into real action requires discipline, perseverance, and then continuously being after a particular focused target. See, otherwise we can be getting lost in multiple directions. See, if you are moving in one direction, even though you are moving only one step at a time, you will reach your destination. But every now and then you decide, oh, this is not good, I'll do this. So you keep changing. So you are all the time you are very energetic and moving, but your directions are all random. It will all average out to zero. So that's where key things is you have infinite potential, you have capability, but then make up your mind and then stick to that, keep working toward that. Success will definitely come. You will actually encounter some difficulties in between.
yes,
Again, I just want to make one point here for appreciation. See, suppose you want to do something which others have not done till now, or which you yourself have not done so far. What does it mean? You have to push yourself beyond your current level of skill and knowledge. Only when you push beyond that, you can get something new. That means if you want to achieve something beyond your current knowledge and skill, you have to push yourself and try to venture into a unknown territory. But then when you are trying to do that, what is more likely, failure or success? Failure is more likely, but then be prepared for them. Prepare yourself for initial failures. Then you know how to recover, how to go ahead. Once you learn that experience, then
yes,
nothing can stop you. You
yes,
can keep moving ahead. So
yes,
basically the point is you should not be deterred by initial failures. That is, if you are not failing, it only means you have not pushed yourself hard enough.
yes,
If you do not push yourself hard enough, you will remain where you are. You cannot move ahead. So that's the real thing. So today opportunity is tremendous. India is moving towards 2047. Space itself, if you see space stations, humans in space, whole lot of activities are there. For future, you want to build rockets which can move 10 times, 100 times faster than this. Why? Because today at our speed, we can reach Mars in 9 months. But you
yeah,
want to reach in 9 days or 9 minutes. So you have to build rockets which can move much faster. That means
yes,
challenges are many. Nature
yes,
always throws challenges. But those humans which are able to observe, capture that concept, translate that into reality, becomes a discoverer, Nobel laureate, or a great individual. And then there are others who will build empire around that and move ahead. So
yes,
opportunity is infinite. Make use of your own ability to observe, your intelligence ability to process, and then use all the other things as tools for your progress.
yes. So it was all about the discussion. So can you give a little message to our team, Achintya, and a little message for BHU students of the BHU?
Yeah, the way I'm seeing is primarily no matter what we do, we have some purpose. See, for example, Achintya, the very by the name itself, you are now trying to look at doing things which not only help you, your team as individual, but also enabling a whole lot of people around you how to bring to their awareness many different aspects of life. So building awareness is the first aspect, both ourselves becoming aware of the situation and also making more and more people aware of the situation. See, if
Yes,
India has to remain an independent, capable country, it will be possible only when we visualize what is happening in the world today. Are there attempts happening to do another type of colonization? Are we becoming victims of such a thing? For that, if we do not look beyond immediate, if we do not build that awareness in more and more people, what is in store tomorrow could be another round of a colonization of a very different kind, of a kind where in the previous case it was physical entanglement, but now intellectually manipulated. But then, if you do not want others to manipulate you intellectually, you need to build competence and you need to make more and more people aware of the likely problems that we will encounter. And that is how we can reach 2047 and be a country which can actually hold its head high and be among the equals.
Yes. So, as a youth of this country, we also hold a dream of seeing our country as a developed nation by 2047. And from this discussion, I can draw a few key points which summarizes the whole discussion of an hour or and minutes. That the youth of this country needs infinite potential and full confidence in their passion and what their interests are, and they just try to mimic the nature and learn what it provides you and what it does. And you should always carry an imagination for your dream and whatever you want to do in your life so that you can make it into a reality. And perseverance is the key to achieve success, and respect your dreams. So, all these points I can draw from this whole discussion, which gives a very beautiful message to our youth to work hard and achieve. And thank you so much, sir, for joining with us and for this wonderful interaction. And